Hello Radiant Scholars, welcome back. Today we're going to be learning about factorizing quadratic expressions and the difference of two squares, which is a special case of a quadratic. So it would be great if we could just jump right into it, but there is a hefty question at the end, as I've said, I think. Have I said that? I don't know. But it's pretty long, so yeah, stay until the end to find out what it is. Right, so the general form of a quadratic is ax squared plus bx plus c. So first two, x squared minus 5x minus 6, x squared plus 6x plus 8 are examples of quadratic expressions. Okay, imagine the question is to factorize these. How are you going to do that? So what we want to do is factorize these into double brackets. So you want to look at what two numbers multiply to give minus 6 and what two numbers add to give minus 5. So why minus 6? Because we're looking at a times c here, and a in the first expression is 1, because there's an invisible 1 here, and c is minus 6, so a times c is minus 6, and then our b is minus 5. So a is 1, b is minus 5, and c is minus 6. So ac is minus 6. What two numbers multiply to give minus 6? Let's write out the factors. 1 and 6, 2 and 3, and that's it, because 3 and 2 is the same thing as 2 and 3. Because we're multiplying two numbers and we're getting a negative back, one of them is going to be negative. I'm thinking it's going to be the top one, 1 and 6, because the difference between them is 5, and that's a good indicator of which factor pair to use. And I am right, because let's make 6 negative, so 1 times minus 6 is minus 6, and then minus 6 plus 1 is minus 5. So we've got our factor pair. Now we factorize it into a double bracket, so you just do x plus 1 and then x minus 6. And that is how you factorize a quadratic expression. So you can check if it's right by just expanding it out like you usually would. X squared minus 6x plus x minus 6. You can collect it, so x squared minus 5x minus 6, and you'll notice that these two are the same. So we did it right. Hooray! Alright, let's do the same thing for the next one. So what multiplies to give us 8? So 1 and 8, 2 and 4, and that's it. And then I think it's the bottom one, because 2 add 4 is 6. So we just put it into our double brackets. X plus 2, x plus 4. X squared plus 4x plus 2x plus 8. You get x squared plus 6x plus 8. Nice. And here at the bottom is a little interesting. It's like kind of a disguised quadratic, because what you can do is you can take out x as a factor, and then you get x squared plus 3x minus 10. And you might notice that this follows the general form of the quadratic, so you can factorize that into double brackets as well. It would be this. So you've got 3 factors which come out of this expression. So that's a neat little trick you might want to remember, to take out a factor from the expression, so it gives you something you can easily or more easily work with. Okay, now we're moving on to the difference of two squares, which I've said is a special case of a quadratic expression. A squared minus b squared. That's literally the difference of two squares, because a squared is a square, b squared is a square, and you're just subtracting it. And it says that that is equal to a plus b, a minus b. So this is useful to know, because in these examples right here, if I could point, we've got x squared, which is a square, and 25, which is a square, and we've got the difference. So what is the root of x squared? Well, we've got x, which x times x is x squared, and then what is the root of 25? Well, we should know that it's 5. Since our a squared is equal to x squared, and then our b squared is equal to 25, then our a is equal to x, then our b is equal to 5. And so we can just use this expanded form here to write out the factorized form for a difference of two squares. So we've got x plus 5 and then x minus 5. And what's special here is that you can remember that the general form for a quadratic expression is ax squared plus bx plus c, but you might notice that here we haven't got a bx because b is 0 and c is negative. Because if you expand this, you'll get x squared minus 5x plus 5x minus 25, and you'll see that these two terms with x in them will cancel out, so you'll just get, well, a difference of two squares. And that's pretty cool, I think. I don't know, but yeah. Alright, moving on to 4x squared minus 9y squared. You could recognize that a is equal to 2x, b is equal to 3y, then you just put it in and factorize it. Nice. Same thing happens, you'll get 4x squared, and then the 6xy's will cancel out. So yeah, move it on. Now we need to factorize a squared minus b squared, and we literally just learned about that. So that's just the difference of two squares, which we can write as a plus b, a minus b. Now part b is where it gets interesting, so hence or otherwise simplify fully something. Yeah, x squared plus 4 squared minus x squared minus 2 squared. So let's work through this slowly so we don't make mistakes. You can notice that this is basically just a squared minus b squared. That's why it says hence or otherwise. You should use what you did in part A to help you work out part B. Here, a is equal to x squared plus 4, and b is equal to x squared minus 2. So in this difference of two squares, it's going to be longer, but it's manageable, because we just do a plus b, a minus b. So a plus b, and then a minus b. And make sure you get the signs right, we're minusing b. So you get minus x squared minus minus 2, which is plus 2. Alright, I'll collect my like terms in these here. So 2x squared plus 2, and then you just get 6 on the side. We need to simplify fully, and there's still a factor I can take out of the left bracket, which is 2. I'll write 6 times here, and then we just took out 2, so it's like that. And then 6 times 2 on the outside is 12. So you've got 12x squared plus 1. Nice, that looks fully simplified. Okay, here's a quadratic expression where a is not 1, and here's where it gets a little bit harder. So remember that we need to find out what two numbers multiply to give AC and add to give B. So here AC is 6 times minus 4, which is minus 24, and B is minus 5. We can write out the factors: 1 and 24, 2 and 12, 3 and 8, 4 and 6. So what looks like it will give minus 5 here? The third pair does, because the difference is 5. What we'll do here is we'll write out the first term, which is the term with the square in it, so 6x squared, and then we'll split up the second term, bx, into 2 terms with x in them. Since it's minus 5, we'll have minus 8 and 3, so we'll have plus 3x minus 8x, which remember gives us minus 5x, but we're splitting up. And then we can just factorize these two halves independently. So we'll take out the biggest factor, 3x, 2x plus 1. Then we've got minus 4 here, 2x plus 1. And if these two are not the same, then you probably did something wrong and you should look over your working. But now we can collect 3x and minus 4 together on the left, and then collect the 2x plus 1 on the right. And that is our factorized form. And here we go. This is the hefty question. Yeah, it looks pretty intimidating at first. If I just check right here, the question's worth only 4 marks, which is kind of crazy. I don't know. I'm kind of lazy. I don't know. I don't want to be doing all of that for 4 marks. But you do what you gotta do. So let's see that we have these square brackets right here. And basically the question is telling us, do the stuff in the square brackets first, or you'll regret it later. So let's do exactly that. We've got x plus 4 divided by a huge algebraic fraction here. And you know when you divide two things, or two fractions I mean, you should know that we're going to use KFC. So keep the left fraction, flip the right, and then change the sign to multiply. So x plus 4 times 2x plus 3 now, because we flipped it over, 2x squared minus 6x minus 56. And so we can see that we have a quadratic on the bottom, which we want to simplify. And yeah, it is pretty hefty. Let's just do that on its own on the side. So 2x squared minus 6x minus 56. So we can take out a factor of 2 here, because everything's divisible by 2. And then we can simplify it easier that way. So we've got minus 7 and plus 4. And then since we're multiplying x plus 4 by the fraction, we can just move up x plus 4 to the numerator. So x plus 4, 2x plus 3, that is a crazy 3, 2, x minus 7, x plus 4, and then you can see that we've got x plus 4 in the numerator and the denominator. So we're going to cancel them out, 2x plus 3 over 2x minus 7. Now it's looking a lot more manageable. Let me just multiply out the denominator, so we got 2x minus 14. So you see how we've taken all of this and we've condensed it down into 2x plus 3 over 2x minus 14. That's crazy. It's definitely a lot more manageable. So let's write it out. Alright, so we can use an easier way to do this rather than cross-multiplying. I mean, we will cross-multiply, but let's make it easier on ourselves. So let's simplify the denominators and take out the biggest factors. So this and this. And you can notice that both of them have x minus 7. So instead of cross-multiplying all of it, we'll just cross-multiply the factors out here. So 2 and 3. So we've got 28 over 6x minus 7. And then 6x plus 9 over 6x minus 7. And that's a lot easier than cross-multiplying all of this. Okay, so now we can put them together on the same fraction. 6x minus 7. Then we've got 6x plus 37 over 6x minus 42. And that is it. That is something. I mean, it's not too difficult, but writing. Writing. So yeah, always be on the lookout for things that will help you in the long run. For example, like how we simplified the denominator here, and then we noticed that we've got the same thing in the denominator, so that helped us a lot. And there's always these little tricks that will help you solve questions easier or make less mistakes on the way. And yeah, we covered quite a lot today, so well done, Radiant Scholars. Always be curious. Always be willing to learn. That is my message for today. I don't know. See you in the next one.